So this is Denise Mathews from Mathews doing lesson 24, session 1 in our math workbooks. So our learning target today is I can divide unit fractions in word problems. Would all the kids say that? Just repeat it to yourself. I can divide unit fractions in word problems. Okay, so I'm going to be working on this board and I'm going to have my presentation right here. You need your workbooks at the same time while I'm doing this so we can do it together just like we do in class, okay? So copy and complete the model to show 2 divided by 1/5. So if we have a number line from 0 to 2, I want you to tell me how many times can 1/5 fit into 2, right? How many times 1/5 can fit into 2? So go ahead and you try it for a few seconds. Okay, I'm gonna work while you work as well. And I'm gonna do some think aloud to myself, like if I were you and my teacher asked me that, what would I do? So 2 divided by 1/5, that means the whole is 5 parts. So I'm gonna divide from 0 to 1 into 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And I'm gonna do the same thing here. 1, 2, 3. 1, 2, 3, 4, 5. So now I've divided this into 1/5, because so this is 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, and 10/5. See that? So let's look at a few things. How many fifths do I have in 2? Should we count it? We're gonna count it all together, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10, right? 10 1/5 in 2. Now let's try it if we were doing it the mathematical way. Shall we do that? So 2 divided by 1/5. What are our 2 rules? Division changes to multiplication and the divisor flips over, right? So let's try that. Those 2 things. 2, that changes to multiply, and this is the divisor, and it flips over. So now it becomes 5/1. 5 times 2 is 10, 10/1. Do we see that? So we get the same answer here and here. Okay? So now we're going to, did you guys get that? We're going to move on to the other slide. All right. So let's read this all together. Okay? So Micah is running a 6-mile race. There are water stops every half mile. And at the 6-mile finish line, how many water stops are there in all? Use a visual model to show your solutions. Okay, so it's kind of difficult for you to see that screen, but if you can follow along in your books, because the problem is the same thing. So let's try to read that one more time, okay? It helps when we read it because it kind of registers in your brain, like what is it that we're asking? So Micah is running a 6-mile race, 6 miles. There are water stops every half mile, and at the 6-mile finish, how many water stops are there in all? Use a visual model to show your solution. So what is this problem about, guys? Yes, it is about running a race and getting water stops. And what are we trying to find out? So we're trying to find out how many stops are there. Did you get that one? You always get it in class, so I know you're gonna get that. Use a visual model to show your solution. So that's what we're gonna be working on. All right? So I want you guys to try this. Let's try to solve your thinking. Let's try to solve this problem. See what we come up with, okay? And after we solve it, I I guess we have no one to tune and talk to. But you can put messages on Classroom, on Google Classroom, and kind of discuss it with whoever is present at the time of you doing this lesson. Okay, so let's see what we're working with. Let's use a model like just blocks. So it's a 6-mile race. All right, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. It's a 6-mile race, and every half mile, and at the 6-mile finish, how many water stops are there? So a water stop is at every half mile. So if this is 1 mile, 2 miles, 3 miles, 4 miles, 5 miles, and 6 miles. But the water stop is at every half mile. So let's say this is a half mile, this is a half mile, this is a half, this is a half, this is a half, this is a half. So the water stops are at every one of those half miles, right? And the question is, how many water stops are there in all? All right, so this is 1 water stop, right? Then there'll be another one here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 water stops in all. Do we see that? Because this is a half mile, you have a water stop at a half mile. This is another half mile, so you'll have another one here, and another one here, and another one here, and so on and so on. So let's try to do this in a math way. So it's 6 divided by half. That's how we interpret what we're going to do mathematically outside of the model, and what our rules, right? Division changes into multiplication, and the divisor flips, right? So 6 multiplied by 2 over 1 is 12. So we have 12 water stops. All right, do we see that? And of course you can tune and talk, but not in real, I guess. Just type your comments, see what other people got, if they got the same thing. If you have any questions, I will check it and respond, okay? All right, so we're moving on to the connecting section. How many water? So we're continuing on lesson 24, session 1. We're gonna look back. How many water stops are there in all? Explain how you can use a number line, which we did already, and there are 12 water stops in all. So let's look ahead a little bit, and it says, on the previous page, you used a visual model to solve a word problem involving dividing a whole number by a unit fraction. You guys remember what a unit fraction is? The numerator is always 1. Yep. So you can use equations to represent and solve these types of problems. So let's look at this word problem. Micah now runs a 5-mile race. So it's 5 miles, right? Okay, let's see. And there are water stops every third of a mile. So we're gonna take these off. So every third of a mile, there are water stops. How many water stops are there in all? Okay, complete the division equation below. So let's look at this. There are 5 miles, and there is water stops for every third of a mile. So every third, so which means we're going to divide this one into thirds. Let's see, 1, 2, 3. 1, 2, 3. See, so this is a third, 2 thirds, 3 thirds, 4 thirds, 5 thirds, etc. So every one is divided into 3. 1, 2, 3. See it? Okay, so it's 5 divided by a third. Right, so that's our problem. And how are we going to solve that? Change the division side to a multiplication, flip the divisor, we get 15. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See that? And we completed both the division and the multiplication problem. And how many stops? 15, right? Explain what it means to divide 5 by a third or 5 divided by a third. Okay, what do you think that means? So that last one, explain what it means to divide 5 by a third. So what does it mean to divide 5 by 1/3? This means how many times can 1/3 fit into 5 wholes? Right? How many groups of 1/3 we could fit into 5? How many times, right? That's what we're looking at. Okay? And then you can do your vocabulary section. I know I always help you with the vocabulary section. So the vocabulary section is going to talk about a fraction model. Right? A fraction model. So let's see some examples of a fraction model. What are fractions? 4/5, right? 2 2/3, that's a fraction model. 2/3. So like 2/3 would be, this is divided into 3, and then 2/3 would be 1, 2. See that? 2 2/3 will be 1, 2, and then just 2/3, right? 4/5 would be, as we have this divided into 5, 1, 2, 3, 1, 2, 3, 4, 5, and then we shade 4 of them. So that's 4/5. Get it? Sorry, I'm off camera a little bit, but you can hear my voice, so that's important. And a visual model that represents a fraction is what it is, right? A visual model that represents a fraction. Okay, and what I know about it, so you can use a number of different things. I can use a circle, bar, or number line to show a fraction model, or to represent a fraction. Got it? All right, so let's look back at our learning target. I can divide unit fractions in word problems. That's what we're looking to. So I think I need you guys to do all of those problems after that lesson. And let me hear what you guys are doing. Put it in your comment section of Google Classroom and I'll check it. All right? Thanks so much. See you on your next lesson. See ya. Bye.